All right, as promised, part 2. All right, 35. The directions state, find the x-coordinates of all points on the graph of f at which the tangent line is horizontal. We just talked about that, so I'm just going to see if we've made some progress practicing that. I would actually pause the video and try that on your own. And then we're just writing an equation of a tangent line at the point x equals 0. So, kind of review of what we've already talked about. So the first thing, to get horizontal tangents, first of all, let's talk about the function that we have. It should be x plus 2 cosine of x. So, tangent lines, got to take the derivative. Derivative of x is 1. The derivative of 2 cosine of x, make sure we keep in line this idea that product rule is unnecessary here because 2 is not a function of x. It's just a coefficient. So, I can take the derivative of cosine, which is negative sine, and put a 2 out front. Horizontal tangents means the slope is 0, so the derivative is 0. All right, solve that equation. I'm going to move the 2 sine of x over here and divide by 2. Now, sine of x is positive up here and up here. And the half is going to be the pi over 6 in both of those quadrants. So pi over 6 here, 5 pi over 6 here. Now, I want to see if there's a restriction in the domain. Do they say it's got to be between 0 and 2 pi? They don't say that. So I need to assume it's all potential points. So at x equals pi over 6 plus 2 pi plus 2 pi, basically all multiples of 2 pi, remember we say 2 pi n, and 5 pi over 6 plus 2 pi n, you have horizontal tangent lines. Again, we're going to double check our answer so that we're not putting false things on the internet. Which one am I even looking at? Okay, yeah, we're good. It works. All right, A's done. Now what about B? What's the tangent line equation at x equals 0? Well, our first step needs to be find the slope of the tangent line, which we've already got the derivative, but instead of setting it equal to 0, f prime of x equals 1 minus 2 sine of x, we are plugging in 0. That's the point that they gave us in the problem in which to find the derivative. Yeah, sine of 0 is 0 times 2, still 0. 1 minus 0, it's 1. So my slope is 1. Step 2, x equals 0, y equals, we got to find it, and we know what n is, it's 1. So you'd plug 0 into the original function, which is 0 plus 2 cosine of 0. Now, if you think about the unit circle, cosine, the x value equals 0 at, or no, we're not doing that. We're saying, here's 0 radians right there on the x-axis. What's the x value when we're at 0 radians? The x value when we're at 0 radians on the unit circle is 1. So my y value is 0 plus 2 times 1. It's 2. So x equals 0, y equals 2, m equals 1. So then we plug in those pieces of information into our slope-intercept form. 2 equals 1 times 0 plus b. So b equals 2. M equals 1, b equals 2. Y equals 1x plus 2. All right. 43. Yes, number 43. Here are the instructions for this one. A point P is moving from left to right along the graph of the equation. Where is the rate of change of y with respect to x equal to the given number? So where is the rate of change with respect of, where is the rate of change of y with respect to x equal the given number a? That's what you're doing. They're saying find the derivative. So y prime, I'll call it dy dx. Remember, you're doing this to both sides. So then x to the 3/2 equals 3/2 x to the, take one away, you're left with 1/2 now. And then take the derivative here. That equals 8. So maybe it would be I don't know. I think it might be easier to visualize this if you just change the x to the 1/2 to root x. So I'm going to subtract the 2 from both sides. 6 equals 3/2 times the square root of x. Remember, 2 is the root, 1 is its power. I can multiply by 2/3 to get rid of the 3/2. That leaves me with 4 on the left-hand side. So where does the square root of x equals 4? Well, it's at 16. Now, I want to be sure of something. What point, and they are specific. They say find the point P, x comma y. So the x coordinate is not good enough. We got to find the y coordinate. So take your 16, plug it back into the original. To get the y value. So I talked about 16 to the 3/2. Situations like that, you can call this 16 times 16 to the 1/2, because this is like 1.5. 16 to the 1 times 16 to the 1/2 is 16 to the 3/2. All right, this is over here 32. This is going to be 16 times its square root, which is 4. Wow, so my y value is 64 plus 32. It's 96. So 16 comma 96 is the point at which this slope of the tangent line is equal to 8. And again, I'm going to double check. We're good. All right, what next? Oh, 45. I like this one. Take the first 4 derivatives of cosine of x. So try that one on your own. All right, let's see what you got. First derivative. The derivative of cosine is negative sine. that showing up better? Marginally. The derivative of negative sine is going to be, sine's just cosine, now it's negative. Take the third derivative. The derivative of cosine is negative sine. Make it negative now. So it's now positive sine. And then it seems like beyond the 3 tick marks, they really don't want you to indicate a fourth derivative with like 4 tick marks. They'll put a little parentheses, almost as if it's an exponent. They'll do this. That's the fourth derivative of f with respect to x. At any rate, the derivative of sine is cosine, so it's positive cosine. So this is my fourth derivative. Now think about this. The fifth derivative is going to be just like my first derivative, because the derivative of cosine is negative sine. We're back to the first derivative. Here's the sixth derivative, and the seventh, and the eighth, and then it just recycles again. So when they're talking about what's the 99th derivative of f of x? Sorry, having trouble talking right now. So 45b. What's the 99th derivative of x? We could probably say, well, the 100th derivative is certainly going to be, I think it's going to be like a multiple of 4 at this point, right? It's every fourth one gives you cosine. Every fourth derivative seems to give you cosine. So the 8th derivative gives you cosine, and the 12th derivative gives you cosine, and the 16th derivative gives you cosine. So if this derivative is divisible by 4, then that is going to be cosine of x. And 100 is divisible by 4. It's 25. So we know that this one's cosine of x. So what's the derivative just prior to it? Sine of x. So the 99th derivative is divisible by the third derivative. The 98th derivative is divisible by the second derivative. See, it's almost like a game of, remember imaginary numbers? When I equals root negative 1, and I squared equals negative 1, and I cubed equals negative 1i, and I to the fourth is equal to positive 1. It basically recycles in the exact same format that your imaginary numbers do. It's got 4 every time. And there's 4 of these symbols too. Those are the ones we work with. So, I guess, first of all, let's double check that answer. 45b, let's hope we didn't make any mistakes. Yeah. Cosine's the fourth. Sine's the 99th. All right, guys. I think I got time for this last one. Is 47 worth our time? I think so. I just want to make sure we got this down. So the third derivative of tangent of x. And again, they've been using all sorts of funky notation. Try this on your own. All right. You paused it, right? And then you tried it on your own, and now you're going to check with me? Good idea. So first derivative. Tangent is secant squared. All right, to find the second derivative of this, you have to call this secant of x times secant of x. And once you do that, well, in order to do that, you have to do product rule. All right, so it's got to be first times the derivative of secant of x plus secant of x times the derivative of the first. Let's do that right now. So if this is f prime still, to get to f double prime, I go first times the derivative of the second, which is secant x tangent x, right, plus the second secant of x times the derivative of the first secant of x tangent of x. Wow. Okay. This is almost not cool. You know what I mean? Like, this is secant squared of x tangent of x plus secant squared tangent of x. Which is two of them. You can combine them and call it you can combine them and give it a coefficient of 2. And now we're supposed to find the third derivative of this? Okay. We trust you, Mr. Owsley. It's okay. All right, I actually want to draw your attention to something interesting from the textbook that I believe they give us in the previous chapter. No, the previous section. It's number 71 on page 117. So go there really quick. I'm supposed to take one more derivative of this. And it looks like we've got 1, 2, 3 functions. Notice on number 71. Okay? Here, I'll hold it up for you. Right? Woo, okay, this is weird. At any rate, it gives you how you find the derivative of three functions using, it's kind of like a variation of product rule. They say, rewrite the first two, take the derivative of the third. So, rewrite the first two, and then take the derivative of the third. The derivative of tan is secant squared of x. Got it. Then they say add. I'll do it vertically. Rewrite the first and the last and multiply by the derivative of the middle. So rewrite the first and the last, and then take the derivative of the middle, which should be secant of x, tangent of x. All right, then the formula goes, very predictable. Take the derivative of the first now, which would be 2 secant x tan x times the second and the third unchanged. Wow. Okay. What do we got here? We've got 2 secant, 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 secant. 2 secant to the fourth. Here, 2 secant squared, tangent squared. And then 2 secant squared, tangent squared. Hey, you can combine those last two. So 4 secant squared x tan squared x plus 2 secant to the 4th of x. And there might be some simplification that can go into that, but I think it's probably a good time to stop. 20 minutes, 30 seconds is a long time for the second part of the video. All right, so good luck. Hopefully this was helpful and not frustrating. Thanks for watching.